Hello, I'm Floyd Maxwell, justthinkit.com. This video is called Consequences of a Spring and Loop Theory, Einstein's Ether Talk. Science depends on organized skepticism, that is, on continual, methodical doubting. Few of us doubt our own conclusions, so science embraces its skeptical approach by rewarding those who doubt someone else's. Neil deGrasse Tyson. The publication of Einstein's special relativity demarks the first great BC-AD split in physics. Before relativity, ether theories dominated, and major physicists were sure there was an ether. After relativity, relativity, first special and then general, dominated, with the ether no longer needed. In time, despite the lack of scientific reason for doing so, the ether was discarded. Today, the ether is denied even the possibility of existing, and ether theorists are viewed with derision. The fratricidal treatment of the ether has never been examined until now. With a nod to Peter Fox's Colombo series, we'll review the state of the ether circa 1920 from the perspective of none other than Albert Einstein himself. The May 5, 1920 talk was originally in German. Einstein's words will appear in black, spring and loop theories in green, and there are 57 uses of the word ether in his talk. Ether and the Theory of Relativity by Albert Einstein. How does it come about that alongside of the idea of ponderable matter, which is derived by abstraction from everyday life, the physicists set the idea of the existence of another kind of matter, the ether? Well, your first mistake is assuming the ether is matter. The ether is everything but matter. The explanation is probably to be sought in those phenomena which have given rise to the theory of action at a distance. Action at a distance is something most physicists are, or should be, troubled with. It has never been completely explained in any theory except spring and loop theory. And in the properties of light, which have led to the undulatory theory. The properties and behavior of light are also unexplained phenomena. There are plenty of rules and equations, but what exactly is a photon? Why is the speed of light the speed limit? And who says the speed of light is constant? Certainly not spring and loop theory that also says a photon is not a particle. Let us devote a little while to the consideration of these two subjects. It is much more than two subjects. Action at a distance affects our conception of how gravity works, how plus attracts minus, what keeps nucleons together, what keeps electrons orbiting the nucleus, and additional areas too numerous to name. The history of physics is the history of giving up cherished ideas. Andrew Strominger. Action at a distance is at the core of what is completely wrong with physics today, and what was completely right with physics 110 plus years ago. Outside of physics, we know nothing of action at a distance. Well, perhaps because there is nothing outside of physics. Full stop. When we try to connect cause and effect in the experiences which natural objects afford us, it seems at first as if there were no other mutual actions than those of immediate contact. Example, the communication of motion by impact, push and pull, heating or inducing combustion by means of a flame, etc. Yes, this is an extended restatement of the problem. It is true that even in everyday experience, weight, which is in a sense action at a distance, plays a very important part. Well, restatement again. No points earned. But since in daily experience the weight of bodies meets us as something constant, the kilogram getting smaller problem suggests weight is not constant. Something not linked to any cause which is variable in time or place. Lack of understanding of the problem is not the same as there being no problem. We do not in everyday life speculate as to the cause of gravity. Speak for yourself. Physicists should speculate as to the cause of gravity. In fact, this is the kind of thing that differentiates true physicists from copiers, catalogers, and sci-fi wannabes. And therefore, we do not become conscious of its character as action at a distance. It is the responsibility of scientists, and in particular physicists, to be conscious of, work on, and ultimately try to resolve such conundrums. Joe and Jane Citizen have no obligations in this area, so it makes no sense to compare ourselves to them. It was Newton's theory of gravitation that first assigned a cause for gravity by interpreting it as action at a distance, proceeding from masses. Newton came up with a formula that described how the gravity effect worked. He found a correlation, but lacking a model, he could not have identified a causation. Newton's theory is probably the greatest stride ever made in the effort towards the causal nexus of natural phenomena. Does the word nexus improve on the word connection? And yet this theory evoked a lively sense of discomfort among Newton's contemporaries because it seemed to be in conflict with, it was and is in conflict with, the principle springing from the rest of experience that there can be reciprocal action only through contact and not through immediate action at a distance. If there was no conflict, or if relativity resolved it, why did you spend the next 30 years trying to figure out gravity? It is only with reluctance that man's desire for knowledge endures a dualism of this kind. It is only by lack of scientific approach that man ignores a problem of this kind. How was unity to be preserved in his comprehension of the forces of nature? Unity comes from simplification. Simplification comes from the best model. The best model comes from the removal of all but the most fundamental assumptions. It ain't what you don't know that counts, it's what you know that ain't so. Will Rogers. Either by trying to look upon contact forces as being themselves distant forces, this would have made things worse, which admittedly are observable only at a very small distance, and this was the road which Newton's followers, who were entirely under the spell of his doctrine, mostly preferred to take. Nonsense. But it is a road fantasy writers love to take. Or by assuming that the Newtonian action at a distance is only apparently immediate action at a distance, but in truth is conveyed by a medium permeating space, whether by movements or by elastic deformation of this medium. Quite so. It is as simple as that. Back to basics for better insight. Blaise Pascal. Thus the endeavor toward a unified view of the nature of forces leads to the hypothesis of an ether. The endeavor toward a more unified view, more unified by more accurately modeling how things behave, but really just more accurately modeling. Unity is an endpoint. You only get there when you put all the pieces of the puzzle together. This hypothesis, to be sure, did not at first bring with it any advance in the theory of gravitation or in physics generally, so that it became customary to treat Newton's law of force as an axiom not further reducible. Yes, Newton's gravity was a "this is all we know so far" moment. Physics is full of these. Ending all thought about an unsolved problem is also what most physicists prefer to do. Got a cure for this disease, Dr. Einstein? But the ether hypothesis was bound always to play some part in physical science, even if at first only a latent part. Yes, the ether will always play a part in physical science. When, in the first half of the 19th century, the far-reaching similarity was revealed which subsists between the properties of light and those of elastic waves in ponderable bodies, the ether hypothesis found fresh support. Right, light propagating through the ether is exactly like sound propagating through solids. The ether has been right in front of us all along. It appeared beyond question that light must be interpreted as a vibratory process in an elastic inert medium filling up universal space. Yes, exactly this. And vibratory processes are not particles. It also seemed to be a necessary consequence of the fact that light is capable of polarization that this medium, the ether, must be of the nature of a solid body, because transverse waves are not possible in a fluid, but only in a solid. No, although a solid ether has been considered, there have been countless other candidates. I suggest a rereading of E.T. Whittaker's authoritative History of the Theories of Ether and Electricity. Freely available online, this 1910 book is quite possibly the most underrated work in all of science. By the way, the notion that only a solid solves the problem is false, in part because there are no solids, none, in the entire universe. The only thing which can be directly perceived by the senses is force. James Clerk Maxwell. Something solid simply provides more resistive force than something liquid, but it is all truly relative. In space, that spring and loop theory models as a universal matrix of spring-like pure energy, higher energy appears more solid than lower energy. The ether is the highest energy there is, therefore it is the most solid-like of any energy system. A better way to look at it is as a box full of ultra-springy marbles. The system is static. The marbles can't move. Once something bumps something, the springy marbles transmit that bump. This model describes what happens quite well, especially spooky action at a distance, but breaks down completely when we go looking for solid marbles. So stop doing that. The ether is not solid, but solid-like in its resistance. The ether is not spring-like, except in how it faithfully propagates bumps of energy. The ether does not move because it has nowhere to move to. The energy mass is evenly distributed everywhere. Thus, the physicists were bound to arrive at the theory of the quasi-rigid luminiferous ether, the parts of which can carry out no movements relatively to one another except the small movements of deformation which correspond to light waves. This interpretation is technically accurate, but until you realize that the ether, i.e. the highest level energy, is everywhere, exactly as calculated by the way, your model contraption will be complicated, and grow more so each day. In the beginner's mind, there are many possibilities. In the expert's mind, there are few. Shunryu Suzuki. In the box full of marbles world of spring and loop theory, there are only two things, ever, anywhere. 1. There are small, ultra-powerful springs of energy. 2. There are lower energy loops, or modifiers or dampeners, of energy, also known as mass or matter. This theory, also called the theory of the stationary luminiferous ether, moreover found strong support in an experiment which is also of fundamental importance in the special theory of relativity, the experiment of Fizeau, from which one was obliged to infer that the luminiferous ether does not take part in the movement of bodies. Something so fundamental deserves a more thorough inspection, so let's begin by familiarizing ourselves via Wikipedia with the Fizeau experiment. Quoting from Wikipedia, according to the theories prevailing at the time, light traveling through a moving medium would be dragged along by the ether, so that the measured speed of the light would be a simple sum of its speed through the medium plus the speed of the medium. Fizeau indeed detected a dragging effect, but the magnitude of the effect that he observed was far lower than expected. His results seemingly supported the partial ether drag hypothesis of Fresnel, a situation that was disconcerting to most physicists. Over half a century passed before a satisfactory explanation of Fizeau's unexpected measurement was developed with the advent of Albert Einstein's theory of special relativity. Einstein later pointed out the importance of the experiment for special relativity. The phenomenon of aberration also favored the theory of the quasi-rigid ether. Okay, so we have proposed a quasi-rigid ether, i.e. a box full of marbles. The development of the theory of electricity along the path opened up by Maxwell and Lorentz gave the development of our ideas concerning the ether quite a peculiar and unexpected turn. It is a pretty big stretch to credit the opening of your ideas concerning the ether, i.e. what became the special and general relativity equations, to Maxwell and Lorentz's work. You came up with your happiest thought after reading and thinking about the work of countless earlier physicists that had to include Samuel Tolliver Preston, Olinto de Pretto, and certainly Henri Poincaré. The remarkable elasticity of the ether proved by the speed it can propagate waves, such as waves of light. Samuel Tolliver Preston, Physics of the Ether, 1875. You extended the theories of these last three, merging their work with that of Maxwell and Lorentz. General relativity is a theory of relationships between mass, light, energy, space, and time. But just as importantly, you neglected to provide a basic model for all of this. For Maxwell himself, the ether indeed still had properties which were purely mechanical, although of a much more complicated kind than the mechanical properties of tangible solid bodies. But neither Maxwell nor his followers succeeded in elaborating a mechanical model for the ether, which might furnish a satisfactory mechanical interpretation of Maxwell's laws of the electromagnetic field. Yes, Maxwell also lacked a working model of the ether, but absence of models is not evidence of absence of ether. The laws were clear and simple, the mechanical interpretations clumsy and contradictory. Almost imperceptibly, the theoretical physicists adapted themselves to a situation which, from the standpoint of their mechanical program, was very depressing. While it can be discouraging to not have a complete solution, there is something more truly depressing: choosing to build off theories you know are wrong. I would call this scientific suicide. They were particularly influenced by the electrodynamical investigations of Heinrich Hertz, for whereas they previously had required of a conclusive theory that it should content itself with the fundamental concepts which belong exclusively to mechanics, example densities, velocities, deformations, stresses, they gradually accustomed themselves to admitting electric and magnetic force as fundamental concepts side by side with those of mechanics, without requiring a mechanical interpretation for them. Well, rather than fundamental concepts, they were compatible or explained concepts. And being able to incorporate, include, or work compatibly with other concepts is a healthier solution than the every theory is broken and none works well with others shambles we have today. Thus, the purely mechanical view of nature was gradually abandoned. More like physics Alzheimer's. Speaking of forgetting, have you forgotten that everything must be geometrical, Albert? Let me remind you, quoting, "Geometry is the most ancient branch of physics. Without it, I would have been unable to formulate the theory of relativity." Albert Einstein. In the context of a complete unified theory of how everything works, calling such a theory mechanical versus geometrical is little more than semantics. The only truly derogatory term would be mathematical. But this change led to a fundamental dualism which, in the long run, was insupportable. Physics, walking away from the ether, became lost, and worse. A way of escape was now sought in the reverse direction by reducing the principles of mechanics to those of electricity. To escape from a grounded, fundamental basis to the realm of equations and 100 years later, make-believe. Facepalm. And this especially as confidence in the strict validity of the equations of Newton's mechanics was shaken by the experiments with B-rays and rapid cathode rays. Granted, there were unaccounted for relativistic effects observed in the nucleus, but by itself this doesn't jeopardize an ether model. At the time, it was unexplained. Then you found it fit within your theory and equations. What of it? 100 years after you, spring and loop theory provides an even more fundamental and complete explanation of that effect and many others that works at all scales, and yet it is built on the ether. This dualism still confronts us in unextenuated form in the theory of Hertz, where matter appears not only as the bearer of velocities, kinetic energy, and mechanical pressures, but also as the bearer of electromagnetic fields. Since such fields also occur in vacuo, i.e. in free ether, the ether also appears as bearer of electromagnetic fields. It is dualism in your mind only. There is one ether behind all phenomena that the existing mainstream physics theories and temp theorists are troubled by, because they are badly broken. Temp theories, that is. The ether appears indistinguishable in its functions from ordinary matter. Well, that is fundamentally true in that both are energies. The key difference is that the ether is much harder than ordinary matter in that it is at a much higher energy and there is nowhere for that energy to go. So it is less compressible in that it takes much more energy to compress it versus the energy required to compress matter. Yet it is less solid than matter in that it is more energy-like than matter-like. In addition, components of the ether, the Planck scale springs, vibrate at the speed of light and are 100 billion times smaller than an atom. Little wonder few have successfully visualized the concept beyond mass equals energy. Within matter, it takes part in the motion of matter, and in empty space, it has everywhere a velocity. To be clear, you are referring here, and just below, to Hertz's theory of the ether. Spring and loop theory says the marbles in that box full of marbles have no velocity, so that the ether has a definitely assigned velocity throughout the whole of space. There is no fundamental difference between Hertz's ether and ponderable matter, which in part subsists in the ether. As soon as you say no fundamental difference, you are in the land of make-believe, or poor comprehension. What would be the point of naming two things differently when they turn out to be essentially the same? The Hertz theory suffered not only from the defect of ascribing to matter and ether on the one hand mechanical states and on the other hand electrical states, which do not stand in any conceivable relation to each other. Once again, just because you could not relate them does not mean they are unrelatable. Non-results, no matter the source, prove nothing. It was also at variance with the result of Fizeau's important experiment on the velocity of the propagation of light in moving fluids and with other established experimental results. Right, Hertz's theory of the ether is flawed. Moving on. Such was the state of things when H.A. Lorentz entered upon the scene. He brought theory into harmony with experience by means of a wonderful simplification of theoretical principles. He achieved this, the most important advance in the theory of electricity since Maxwell, by taking from ether its mechanical and from matter its electromagnetic qualities. As in empty space, so too in the interior of material bodies, the ether, and not matter viewed atomistically, was exclusively the seat of electromagnetic fields. Right, the ether is the seat of everything. According to Lorentz, the elementary particles of matter alone are capable of carrying out movements. Lorentz is wrong, in perhaps a subtle way. Quite undeservedly, the ether has acquired a bad name, Frank Wilczek. Matter can move matter, but springs, i.e. the ether, can and do bump into springs, providing the motive force behind zero-mass particles like photons. Photons are moved, i.e. propagated, by and through the ether, and only the ether. In addition, springs can transmit force to matter loops via electrons, currently theorized by spring and loop theory as one of the smallest spring loop systems. And this, of course, works in reverse as well. Their electromagnetic activity is entirely confined to the carrying of electric charges. Once again, this is equations and theory without a model. Charges attracting their opposite, for example, is more action at a distance, a model breaker in itself. Thus, Lorentz succeeded in reducing all electromagnetic happenings to Maxwell's equations for free space. How is this progressive? To rest upon a formula is a slumber that prolonged means death. Oliver Wendell Holmes, Jr. We introduced the rats to cocaine and they stopped pushing the food button. Yes, you did, and they did, but as to the mechanical nature of the Lorentzian ether, it may be said of it, in a somewhat playful spirit, that immobility is the only mechanical property of which it has not been deprived by H.A. Lorentz. It may be added that the whole change in the conception of the ether which the special theory of relativity brought about consisted in taking away from the ether its last mechanical quality, namely its immobility. And this was the moment the ether was lobotomized. Interesting that this happened just a few years before the Fed did the same thing to the US dollar. How this is to be understood will forthwith be expounded. The space-time theory and the kinematics of the special theory of relativity were modeled on the Maxwell-Lorentz theory of the electromagnetic field. Others have commented on Einstein not giving sufficient credit to his predecessors. Careful perusal of Einstein's writings reveals that he gave credit on numerous occasions, as he does here. This theory therefore satisfies the conditions of the special theory of relativity, but when viewed from the latter it acquires a novel aspect. For if K be a system of coordinates relatively to which the Lorentzian ether is at rest, the Maxwell-Lorentz equations are valid primarily with reference to K, but by the special theory of relativity, the same equations, without any changes of meaning, also hold in relation to any new system of coordinates K', which is moving in uniform translation relatively to K. Now comes the anxious question, why must I, in the theory, distinguish the K system from all K' systems, which are physically equivalent to it in all respects, by assuming that the ether is at rest relatively to the K system? For the theoretician, such an asymmetry in the theoretical structure with no corresponding asymmetry in the system of experience is intolerable. If we assume the ether to be at rest relatively to K, but in motion relatively to K', the physical equivalence of K and K' seems to me from the logical standpoint not indeed downright incorrect, but nevertheless unacceptable. So, you make some assumptions, then point to breakage of Lorentz's theory caused by your assumptions. The next position which it was possible to take up in the face of this state of things appeared to be the following: the ether does not exist at all. Yikes, sound the klaxon. You've done nothing to disprove ether theory. No one has. Discarding it here is foolhardy at best. This moment is like a young driver discarding their seatbelt and reassuring themselves when the car keeps moving without it. All that has been shown here is that, number one, the ether as a system is independent of any matter system, from a movement from A to B point of view, and number two, Lorentz's version of the ether has an invalid assumption. Nothing more can be concluded. The electromagnetic fields are not states of a medium, and are not bound down to any bearer, but they are independent realities which are not reducible to anything else, exactly like the atoms of ponderable matter. Well, that's the worst sentence you've ever authored, Albert. With it, your model complexity went to infinity, and sadly, you failed to notice the calamity. This conception suggests itself the more readily as, according to Lorentz's theory, electromagnetic radiation, like ponderable matter, brings impulse and energy with it. As already explained, the ether can and does bring impulse and energy with it, so, at best, your proposition is a second possible solution. Except it isn't. Instead of a unification, it is a fragmentation. And Babel, version 1, is officially launched. I was to learn later in life that we tend to meet any new situation by reorganizing, and a wonderful method it can be for creating the illusion of progress while producing confusion, inefficiency, and demoralization. Petronius, 1st century. By the way, if Lorentz's ether model was flawed, why were you comparing Babel version 1 to it? In the world of theories, flawed equals useless. Referring back to it ever is fatal. Fix flawed theories, or vaporize them from orbit. The fate of humanity depends on it, at least. And as, according to the special theory of relativity, both matter and radiation are but special forms of distributed energy, ponderable mass losing its isolation and appearing as a special form of energy. Not that it is relevant to any discussion of the ether, and not that I agree with your conclusions, but at least two typos can be corrected. Losing should be loses, and appearing should be appears. More careful reflection teaches us, however, that the special theory of relativity does not compel us to deny ether. I find flip-flops uncomfortable to wear. We may assume the existence of an ether, only we must give up ascribing a definite state of motion to it. Agreed, already. There is no motion to the ether. A box full of marbles does not allow the marbles to move around. But marbles can still propagate vibration, the radiation you mentioned, from one marble to the next. I.e., we must by abstraction take from it the last mechanical characteristic which Lorentz had still left it. No, the ether can still behave like a spring, and is more than capable of propagating photons and other forms of radiation, as well as interacting via electrons with mass. We shall see later that this point of view, the conceivability of which I shall at once endeavor to make more intelligible by a somewhat halting comparison, is justified by the results of the general theory of relativity. It is rather curious that 5 years after you published General Relativity, the supposed superset, you've based at least half this talk on special relativity. Special relativity proposes numerous revolutionary concepts that are widely accepted today and beautifully illustrated in countless exploding star animations, but it applies to a universe without accelerations and without gravity. Special relativity can't be applied to our universe, yet you have extensively referenced it here. Most curious. In mathematics, you don't understand things, you just get used to them. John von Neumann. Given the issues with your special thoughts so far, it's impossible to imagine your general thoughts improving anything. Yet, by definition, even more is built off of them. The notion of taking a gravity-less special relativity, tweaking or changing it in one or more ways, and proclaiming a generalized theory, when gravity is so absolutely fundamental to everything, but the ether, ironically, is rather mind-blowing. Think of waves on the surface of water. Here we can describe two entirely different things. Either we may observe how the undulatory surface forming the boundary between water and air alters in the course of time, or else, with the help of small floats, for instance, we can observe how the position of the separate particles of water alters in the course of time. If the existence of such floats for tracking the motion of the particles of a fluid were a fundamental impossibility in physics, if, in fact, nothing else whatever were observable than the shape of the space occupied by the water as it varies in time, we should have no ground for the assumption that water consists of movable particles, but all the same we would characterize it as a medium. Your water-air medium is unlike the universal medium. There is no air in the universal matrix of springs. The box full of marbles has nothing else in it, and, being full, permits no movement within it, i.e. the ether. By the way, in addition to the forms of movement already mentioned, there is yet another type of movement. Space is expanding. The marbles in the box full of marbles are getting bigger. We have something like this in the electromagnetic field, for we may picture the field to ourselves as consisting of lines of force. If we wish to interpret these lines of force to ourselves as something material in the ordinary sense, we are tempted to interpret the dynamic processes as motions of these lines of force, such that each separate line of force is tracked through the course of time. From the perspective of spring and loop theory, I'm not sure you said anything valid there. It is well known, however, that this way of regarding the electromagnetic field leads to contradictions. Right, a nonsensical paragraph. Thought so. Generalizing, we must say this. There may be supposed to be extended physical objects to which the idea of motion cannot be applied. You lost me again. They may not be thought of as consisting of particles which allow themselves to be separately tracked through time. Telling me what they are not is not very helpful. In Minkowski's idiom, this is expressed as follows. Not to be rude, but how about in your idiom? Not every extended conformation in the four-dimensional world can be regarded as composed of world threads. Things are getting darker, not lighter. The special theory of relativity forbids us to assume the ether to consist of particles observable through time, but the hypothesis of ether in itself is not in conflict with the special theory of relativity, only we must be on our guard against ascribing a state of motion to the ether. I think these 3 sentences repeat the single point made earlier: no movement of the ether, agreed on already. Certainly from the standpoint of the special theory of relativity, the ether hypothesis appears at first to be an empty hypothesis. Wikipedia, Google, and I were unable to figure out what an empty hypothesis is. Interpreted here as, Einstein got nothing out of the ether. This is your loss and of no consequence to ether theory. In the equations of the electromagnetic field there occur, in addition to the densities of the electric charge, only the intensities of the field. Your electromagnetism is distinct from ether and matter, and is rather like string theory's Calabi-Yau shapes, an attempt at solving everything. Both fail to come anywhere close to unifying things. So frankly, who cares? The career of electromagnetic processes in vacuo appears to be completely determined by these equations, uninfluenced by other physical quantities. I feel like a comedian being fed perfect setup lines. You wouldn't know an influence if it... Slightly more seriously, I think we need a little more from your theory than appearances, because appearances can be deceiving. The electromagnetic fields appear as ultimate irreducible realities. Fanaticism consists of redoubling your efforts when you have forgotten your aim. George Santayana. Can we have less of the inflexible, brittle concrete of your proclamations, and more of the malleable, durable rebar any good theory needs to be built on? And at first it seems superfluous to postulate a homogeneous isotropic ether medium and to envisage electromagnetic fields as states of this medium. The laser was also seen as superfluous at first. In this case, however, you make the more serious mistake of assuming your electromagnetic field dream world has anything to do with reality. But on the other hand, there is a weighty argument to be adduced in favor of the ether hypothesis. Sage starves, since serial seesawing sickens stomachs. Look, ether theories were there first. You come along, are unable to live with the ether theory, and throw it out. This necessarily complicates your own theory. But, defiantly, you say that you don't need an ether. But on the other hand, these are truly inconsistent thought sequences. To deny the ether is ultimately to assume that empty space has no physical qualities whatever. Well, good luck with either thought. The fundamental facts of mechanics do not harmonize with this view. What view? You lost me completely. If you are saying there are physical qualities to space, then what else but the ether is responsible? If you're saying there aren't physical qualities to space, well, I can't help you. Either way, it seems you need help here, which is quite awkward as spring loop theory is the very last thing on Earth likely to provide it to you. For the mechanical behavior of a corporeal system hovering freely in empty space depends not only on relative positions, distances, and relative velocities, but also on its state of rotation, which physically may be taken as a characteristic not appertaining to the system in itself. I'm starting to get a headache, but for those still trying to keep track, replace corporeal with physical, and not appertaining to with of. In order to be able to look upon the rotation of the system, at least formally, as something real, Newton objectivizes space. Since he classes his absolute space together with real things, for him rotation relative to an absolute space is also something real. Newton might no less well have called his absolute space ether. What is essential is merely that besides observable objects, another thing, which is not perceptible, must be looked upon as real, to enable acceleration or rotation to be looked upon as something real. And, in 15 times fewer words, Newton looked at everything as physical. Quoting from yourself again, Newton was the first to succeed in finding a clearly formulated basis from which he could deduce a wide field of phenomena by means of mathematical thinking, quantitatively, logically, and in harmony with experience. Albert Einstein. It is true that Mach tried to avoid having to accept as real something which is not observable by endeavoring to substitute in mechanics a mean acceleration with reference to the totality of the masses in the universe in place of an acceleration which reference to absolute space. In other words, Mach tried to do this as well. But inertial resistance opposed to relative acceleration of distant masses presupposes action at a distance, and as the modern physicist does not believe that he may accept this action at a distance, he comes back once more, if he follows Mach, to the ether, which has to serve as medium for the effects of inertia. It would be easy to interpret large portions of this talk as pro-ether, including the previous sentence. But this conception of the ether to which we are led by Mach's way of thinking differs essentially from the ether as conceived by Newton, by Fresnel, and by Lorentz. Mach's ether not only conditions the behavior of inert masses, but is also conditioned in its state by them. Spring and loop theory would agree with Mach. Physics is experience, arranged in economical order. Ernst Mach. Mach's idea finds its full development in the ether of the general theory of relativity. Oh good, we're back to you talking of your theory, right? According to this theory, the metrical qualities of the continuum of space-time differ in the environment of different points of space-time and are partly conditioned by the matter existing outside of the territory under consideration. More simply, in relativity, space-time differs from place to place, and due to any matter that may be present. This space-time variability of the reciprocal relations of the standards of space and time, or perhaps the recognition of the fact that empty space in its physical relation is neither homogeneous nor isotropic, compelling us to describe its state by 10 functions, the gravitational potentials GMN, has, I think, finally disposed of the view that space is physically empty. I think I just disposed of my lunch. Succinctly, in relativity, space is physically empty. But therewith the conception of the ether has again acquired an intelligible content, although this content differs widely from that of the ether of the mechanical undulatory theory of light. What? The ether of the general theory of relativity is a medium which is itself devoid of all mechanical and kinematical qualities, but helps to determine mechanical and electromagnetic events. Does that make the tiniest bit of sense to you, Albert? Your ether has no mechanical qualities, but determines mechanical events? The only thing more shocking than this talk is that 95 years' worth of physicists let it all slip by. I can believe a thing without understanding it. It's all a matter of training. Dorothy Sayers. What is fundamentally new in the ether of the general theory of relativity as opposed to the ether of Lorentz consists in this, that the state of the former is at every place determined by connections with the matter and the state of the ether in neighboring places, which are amenable to law in the form of differential equations, whereas the state of the Lorentzian ether in the absence of electromagnetic fields is conditioned by nothing outside itself and is everywhere the same. With brevity, Lorentz's ether doesn't change. Mine does. The ether of the general theory of relativity is transmuted conceptually into the ether of Lorentz if we substitute constants for the functions of space which describe the former, disregarding the causes which condition its state. Why bother doing this? Earlier you found problems with Lorentz's ether, yet you want to show how yours and his are related? That can't possibly help your theory. Thus we may also say, I think, that the ether of the general theory of relativity is the outcome of the Lorentzian ether through relativation. There are probably more obscure words than relativation, but not many. Google returns just 5,720 hits. Wikipedia has no occurrences. General relativity contains within itself the seeds of its own destruction, Dennis Sciamma, and Babel has been upgraded to version 2. As to the part which the new ether is to play in the physics of the future, we are not yet clear. Well, that much is clear. Quoting from yourself again, Albert, I have now struggled with this basic problem of electricity for more than 20 years and have become quite discouraged, though without being able to let go of it. I am convinced that a completely new and enlightening inspiration is needed. I also believe, on the other hand, that the flight into statistics, i.e. quantum mechanics, is to be regarded only as a temporary expedient that bypasses the fundamentals. Albert Einstein, 1938. You spent the next 18 years on this problem, without results, all because you opted for equations instead of a simple, fundamental, basic model. We know that it determines the metrical relations in the space-time continuum, example, the configurative possibilities of solid bodies, as well as the gravitational fields, but we do not know whether it has an essential share in the structure of the electrical elementary particles constituting matter. I challenge anyone on the face of the earth to get something useful out of that last paragraph. 100-year time limit, go. Nor do we know whether it is only in the proximity of ponderable masses that its structure differs essentially from that of the Lorentzian ether. I don't understand the repeated references to Lorentz's ether. Whether the geometry of spaces of cosmic extent is approximately Euclidean, but we can assert by reason of the relativistic equations of gravitation that there must be a departure from Euclidean relations with spaces of cosmic order of magnitude, if there exists a positive mean density no matter how small of the matter in the universe. So if, some hypotheses without basis, and a bunch of equations, then some sort of difference from something a couple of thousand years old sounds valuable. In this case, the universe must, of necessity, be spatially unbounded and of finite magnitude, its magnitude being determined by the value of that mean density. It turns out Einstein's cosmological constant, or greatest blunder, was fabricated from nothing, a series of if this then that's, built on flawed assumptions. The cosmological constant is a monumental issue not only for cosmology but for particle physics, because it has to emerge from fundamental physics. It has profound implications. Paul Steinhardt. Yet history has given Einstein a pass on this one, saying he was right the first time. If we consider the gravitational field and the electromagnetic field from the standpoint of the ether hypothesis, we find a remarkable difference between the two. You made this difference. You defined it. You punted and wonder why you can't find the ball. There can be no space, nor any part of space, without gravitational potentials, for these confer upon space its metrical qualities, without which it cannot be imagined at all. Totally agree. The existence of the gravitational field is inseparably bound up with the existence of space. Gravity needs both space and matter. No matter, no gravitational field. So half marks. On the other hand, a part of space may very well be imagined without an electromagnetic field. Thus, in contrast with the gravitational field, the electromagnetic field seems to be only secondarily linked to the ether. Honestly, I've lost hope in your definition of the electromagnetic field and your ether. Spring and loop theory cannot imagine space without an electromagnetic force, effect, or interaction. And spring and loop theory has never liked the word field. It's too vague, and it's not about to start using it now. The formal nature of the electromagnetic field being as yet in no way determined by that of gravitational ether. You chose to split the ether from the electromagnetic, so you're on your own on this one, Albert. From the present state of theory, it looks as if the electromagnetic field, as opposed to the gravitational field, rests upon an entirely new formal motif. Couldn't disagree more. As though nature might just as well have endowed the gravitational ether with fields of quite another type, for example with fields of a scalar potential instead of fields of the electromagnetic type. Nope, but then you spent the next 30 years trying to figure out what gravity was, so I understand your guess here. By the way, gravitational ether makes as much sense as positive-negative. Since according to our present conceptions, the elementary particles of matter are also, in their essence, nothing else than condensations of the electromagnetic field, our present view of the universe presents two realities which are completely separated from each other conceptually, although connected causally, namely, gravitational ether and electromagnetic field, or, as it might also be called, space and matter. I'll be gentle. Number 1. Matter is not electromagnetic condensate. Number 2, as mentioned, gravitational ether makes no sense, neither by itself nor, number 3, as space, nor, number 4, as matter, leaving the electromagnetic field, number 5, without the field. Hug? Of course, it would be a great advance if we could succeed in comprehending the gravitational field and the electromagnetic field together as one unified conformation. Quoting from yourself, I do not like it when it can be done this way or that way. It should be this way or not at all. Albert Einstein. You broke them apart and now want them back together? Such vacillations. Whatever you do, Herr Einstein, avoid a career in diplomacy, or maybe consider one. Then, for the first time, the epoch of theoretical physics founded by Faraday and Maxwell would reach a satisfactory conclusion. Well, your then didn't work out, and 93 years have elapsed. Being right too soon is socially unacceptable. Robert Heinlein. You're welcome. The contrast between ether and matter would fade away, and through the general theory of relativity, the whole of physics would become a complete system of thought, like geometry, kinematics, and the theory of gravitation. Divide and unify doesn't work, bud. And, quote, the contrast between ether and matter, quote, is very much meant to be there. Duality is the cornerstone of life. Imagine Paul McCartney without Stevie Wonder, drinking without hangovers, or income without taxation. What the government is good at is collecting taxes, taking away your freedoms, and killing people. It's not good at much else. Tom Clancy. An exceedingly ingenious attempt in this direction has been made by the mathematician H. Whale, but I do not believe that his theory will hold its ground in relation to reality. Quoting from Wikipedia, Weyl tracked the development of relativity physics. In 1918, he introduced the notion of gauge, and gave the first example of what is now known as gauge theory. Weyl's gauge theory was an unsuccessful attempt to model the electromagnetic field and the gravitational field as geometrical properties of space-time. Spring and loop theory would add that gauge theory scored rather poorly in comparing physics theories. Further, in contemplating the immediate future of theoretical physics, we ought not unconditionally to reject the possibility that the facts comprised in the quantum theory may set bounds to the field theory beyond which it cannot pass. Not to worry, quantum theory's failings make it a threat to nothing. Recapitulating, we may say that according to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. Do we celebrate or commit seppuku? And since when does a Japanese word have a 3-letter syllable? For that matter, why is harikiri, more typically spelled, popular outside of Japan? So confused. According to the general theory of relativity, space without ether is unthinkable. That's for sure. For in such space there not only would be no propagation of light, agreed, but also no possibility of existence for standards of space and time, measuring rods and clocks. Where did this come from? May I suggest moving it to the deleted scenes? Nor therefore any space-time intervals in the physical sense. We'll be right back to talking about the ether, folks. Stay with us. But this ether may not be thought of as endowed with a quality characteristic of ponderable media. Einstein's ether colors don't run. As consisting of parts which may be tracked through time, the idea of motion may not be applied to it. Yes and no, as covered earlier. And so it ends, anticlimactically repeating itself, for the nth time. No wonder physics jumped on the relativity bandwagon. Wait, what? A physical theory can be satisfactory only if its structures are composed of elementary foundations. The theory of relativity is ultimately as little satisfactory as, for example, classical thermodynamics was before Boltzmann had interpreted the entropy of probability. Albert Einstein. One extended footnote. The Michelson-Morley experiment is considered to have dealt the ultimate death blow to the ether. Michelson's 1907 Nobel Prize notwithstanding, the fact is that the Michelson-Morley experiment found nothing, and thus proves nothing. Shortly afterwards, the Michelson-Morley's non-result, the apparatus was repurposed to attempt a more precise measurement of the speed of light. A prudently income-maintaining move by Michelson, this can also be viewed cynically as a quick move away from a non-result. Worse, the rest of physics moved as well, from the obvious, the reasonable, and the explained, to equation-created problems and conjectures. Today, physics sits in a pile of mud. 110 years ago, E.T. Whittaker's History of the Theories of Ether and Electricity documented, in staggering detail, the world of the ether, and the highly scientific physicists who tried to figure it all out. Turns out, all they were missing was the right model that spring and loop theory now provides. Relativity, quantum uncertainty, and particle wave particles. Good riddance, Higgs-Goldberg device. And please hold the laughter as we say ta-ta to the preposterous inflationary period of the religious Big Bang. The ether lives, and on even-numbered days, Einstein agrees.